Welcome back to Earth Vimarsh. This video provides a summary of Chapter 5, that is choice. In this video, we'll be first of all discussing what do we mean by when we are saying that optimal choice of a consumer. Then we'll be looking into the concept of consumer demand in terms of optimal choice by taking the same examples which we have been discussing so far with reference to the preferences. Then we'll be talking about how to go about estimating the utility functions. Then what are the implications of the condition of the MRS, that is marginal rate of substitution. And finally, what or how the taxes reflect on the consumer budget constraint, which basically has implications for our choice as well. So under that we'll be talking about the quantity tax and the income tax. So let's begin. Now to begin with, why we are talking about choice here is simple, because as we have seen in our previous chapters that as a consumer you have your budget, which we have been defining with M as a function of your price times commodity. For example, we have been taking the case of two goods wherein X1 and X2 were the two goods. So you were representing your budget constraint with the expression of P2X2. Now this can go up to N, right? It will be equal to summation price time quantity 1 to N, right? So given that budget set and a set of preferences, now what do we mean by preferences? The preferences can be, in terms of a function which may be comprising of a perfect substitute, perfect complement, or quasi-linear preferences, the Cobb-Douglas preferences, all those preference orderings which we have been representing with the help of the indifference curves, right? So given these two things, like you had the budget given and also the preferences, we were talking about like what optimal combinations will be there for the consumer, right? So obviously consumer has to arrive at a choice, right? And what choice will be optimal for a consumer, we are basically going to talk about that where is the point, or in terms of the graph or even in terms of the equation, where will that particular bundle which we can call as optimal will be lying. So this will be occurring at a point where your indifference curve is going to be tangent to the budget line. If you can recall, what was the slope of our indifference curve called? It was the MRS, right? And the slope of the budget line was given or represented with the price ratios, right? If you divide this expression simply with the price, okay, taking one of the price as numeraire, as discussed in the previous videos, you can revisit the budget constraint video if you are not clear with how we come at the get the slope from this budget line, right? So the condition is that they should be tangent. The objective here is to determine that how a consumer with particular preferences will choose a bundle. Now, like for instance, a consumer may be having convex preferences, or maybe he has a preference in a way that the things are like perfect substitutes kind of function. He has a utility function of this form. It can be in the form of this. It can be the form of Cobb-Douglas, like x to the power a, x2 raised to the power b kind of ordering of the utility function. So it depends, right? Your indifference curve shape will also vary depending on the preferences, and budget constraint may vary from consumer to consumer. So your optimal is going to be different, right? So from the previous chapter, we have observed that we can find the slope of the budget line, which is the price ratio, right? And it tells us that how the consumer is able to trade one good for the other in the market. And also we saw that how to find the slope of the indifference curves, which was the MRS, right, marginal rate of substitution, and which basically tells us how the consumer is willing to trade one for the other good, right? And finally, when we are combining these two concepts, we are arriving at what we are terming here as optimal bundle. Now if you observe here, like we have the budget line AB, okay, this AB is the budget line given, and we have different set of indifference curves, IC1, IC2, IC3, IC4, IC5, right? So what we are trying to emphasize here is that our optimal combination is going to be the point where our budget line AB is going to be tangent to the indifference curve, which is IC1 here. Sorry, IC2, right? So IC2 at point P is tangent to the budget line AB. So this is the point of optimal combination, but it should be noted that here also it's important that the condition of monotonicity, right, which means that more is always better, that increased indifference curve, if your indifference curve, okay, it's going up, it's always going to be better for you as a consumer. So more is always better, it should hold. Along with that, your convexity condition should also hold, right? Why it should hold, I'll be emphasizing on that in the subsequent section. But right now you should note that where our optimal combination is going to lie, it will be a point where your tangency of the budget line is going to be with the indifference curves, which essentially means the slopes are going to be equal. And for the budget line, we know that the slope is given by the ratio of the prices, right? So the ratio of the price is going to be equal to the MRS. Now, given the outline, just consider a consumer with well-behaved preferences, which means that he has monotonic set of preferences, wherein more is always better, that is non-satiation, and they are convex, that is averages are always preferred to the extremes. Like in the preferences chapter, we have already discussed these key set of assumptions which are there. I request you to revisit them if you are not clear with that. Like for instance, a consumer has a particular indifference curve IC prime, and if A and B are the 2 points representing the preferences, possible preferences, if a point C is taken such that point C is the average of these two set of preferences A and B, C is always going to yield more utility to the consumer, because even based on the principle, of non-satiation, more is always better, right? If you observe, the utility he is going to get is always going to be greater than what he was getting at A or B, because he always preferred consuming both, right? This was our assumption. And at point C, he's getting more of A as well as more of both A and B, additional, if you combine, they are more at C, right? The combination is bringing greater utility when a mix of both A and B, X1 and X2 is going to go up, right? So this is what it is implying. And since we know that consumer always prefers more, like I mentioned, so we can restrict our focus to the bundles on the budget line as opposed to the ones which are lying in the interior set. Now say for instance, given this budget line AB, okay, there is a consumption bundle which may lie here at point P or Q as well, right? We are not going to consider these cases simply because of they are not in line with these assumptions of the preferences. We assume that the preferences are going to be well behaved, that consumer is always going to prefer more, right? More is always better. So which means if he has a choice to choose among P, Q and R, he is always going to be choosing R, right? And convexity implies that average is going to be preferred over the extremes, all right? So further, he has convex preferences, that averages are preferred to extremes, and therefore consuming all of one good is not optimal, right? Like I emphasized here in this figure, that consuming at point A will yield him greater utility maybe from X2, okay? Here X2 is greater than X1, and at point B, X1 consumption is greater than X2 good, but at point C, they both are, jointly giving more utility based on this assumption. So we will start A at a bundle that is definitely not optimal, okay, and move on to the one which is optimal. Like we'll be talking about a case where we'll be first of all looking into a suboptimal or non-optimal bundle, and then we'll be observing that how to move towards optimal combination. Now if you observe this figure here, so you have three indifference curves, I1, I2 and I3, with the budget line AB. Now given this set of preferences and the budget line, let us say that a consumer is initially at point A, wherein you have x1 and 0 combination, like because your x1 is going, entire budget is getting spent on x1, obviously with this set of preferences and budget line. If you are at, a consumer is consuming at point A, it means that he is consuming only x1 and x2 is 0, so that's why it represented as x1 comma 0. Now what we are trying to do here is that as we moved leftward towards the budget line, horizontally, if you observe, if we move left up, which means we are essentially moving on the budget line towards left, so the indifference curves keep on increasing. Like for instance, we were at I1 initially, and when we kept moving further up, we arrived at I2, right? And if we kept moving from here, further left up, we will be reaching a point like, say for instance, Q and then R as well. But now notice, as you kept moving, like after a certain point here, you are again moving to a point where your combination of x1 and x2 is going to decrease, right, shrink at point Q, or if you compare a point like R as well, right? So if a point like S is there, you can see that obviously S is going to be a better condition, for optimal choice as compared to Q and R, given the assumptions which we have discussed, right? So had it been that an indifference curve would have been tangent through this point, pardon me for this poor drawing, but yeah, if had it been it was tangent from this point, so say for instance this was I4, indifference curve 4, okay, so had it been that it was tangent to point S, this would have been the optimal combination, as it is in line with the assumptions as well, right? But yeah, so as we are moving left upward, we are stopping at the point of tangency of AB with the indifference curve. But if you see beyond this point, okay, if I go beyond this point, like for instance the tangency condition was at point S, but when I'm moving beyond S, what is happening? For the left upward, you are arriving at point like Q, where again it's the combination is not in line with the assumptions, in terms of yielding you what would be more optimal, right? So this is essentially what we are emphasizing here. Now finally, the bundles which we have been discussing, like in our previous figure, we had taken as I4 indifference curve, which was yielding us the optimal combination, which was further in line with the preferences as well. This was I1, this was I2, this is I3, and we assumed I4, which was tangent at point S. So this point basically, okay, this was yielding us a combination of X star and Y star. For example, let us say this is Y and this is X. As per the description here, I am just changing the representation in the graph. So this is going to be X and this is going to be Y instead of X2. Okay, this is X and Y. So this point of tangency is going to be the point where we have the optimal choice when the set of preferred bundles do not intersect the budget line. So what we conclude from this discussion is that utility maximizing point, okay, assuming that there is interior solution, obviously beyond this we cannot move, it's not affordable. Obviously your budget set is AB, so you have to find a solution either on the budget line or the point inside this. And why can a consumer not settle at a point inside? Because it's not in line with what ought to be the optimal point given our assumptions, right? Because he always prefers more. So it's a point where we are observing a tangent between the budget line and the indifference curve, which is on AB I4. Okay. Now, as we have been emphasizing that for tangency to hold, we must be able to assume that these preferences are going to be well behaved, that in a way you have strictly convex preferences and they are going to be monotonic in nature, right? But are there any exceptions to this? So let's see at two key cases. Now say for instance in this figure 1, this is figure 1, okay, you have this kind of preferences, IC1, this is indifference curve 2, this is IC3, okay, and for x1 x2 this is the budget line AB which you have. Now if preferences are in a way, like for example you have a point which seems like a tangent point, okay, because for instance this kind of ordering you will observe for kinged preferences which we have discussed earlier as well. So say for example if the preferences are going to be kinged, okay, this is for kinged preferences. So for kinged preferences you observe that though the point looks like as if it's tangent to the budget line AB from IC2, but it's more of in mathematical sense. If you observe, this is a point which is more like a point where multiple tangents can be there, right? Because a point where the function basically, okay, is completely changing its nature. It's not a continuous function, right? From a point which is like this, right? So definitely it's not in line with that assumption which we need for our preferences. So in that sense, because it has more of a corner solution, it's not in line with what we will expect to be providing us an optimal solution, with the condition that there should be a tangency of the indifference curve to the budget lines. And the other case is for the quasi-linear preferences, which you know were represented in the graph with this kind of shape, right? Or I mean one of the budget line touching the axis, I mean only one of the good. For instance, if this is your budget line and your preferences will be in a way that you are again having a corner solution like this, your indifference curve will be tangent to the budget line AB at a point like this, at point like B, wherein again it's not tangent to the budget line, rather there is an intersection. And here also in the first example you will observe it's more of an intersection, right, to the budget line. It's very difficult to determine whether, I mean multiple tangents obviously are possible through this point. So this is not in line with that. So and they both are non-differentiable. I mean if we talk about in functional form, so both are non-differentiable. So primarily because of these reasons these two exceptions are there. And when preferences are not strictly convex, because we have been emphasizing again and again that they ought to be strictly convex, uh, if that tangency, one tangency condition has to hold for an optimal, we are not looking for multiple optimal like thing, right? There is no multiple optimal solution. So we were looking for one optimal combination of x1 and x2, and that will hold only if and only if when you have strictly convex preferences, okay, and no more than one tangency. Now consider the figure 2, okay. Now you will observe, for example, a function which is increasing or decreasing continuously. It's having 2 points of tangency, right? Here also you can expect an optimum, here also you can expect an optimum, right? But yeah, like if one questions that I mean when we cannot use the tangency condition, what we ought to do is that we have to resort to our economic intuition behind the problem which is under consideration, the function which we are studying, and specifically looking it in terms of the graph, okay, trying to visualize it. It can tell us whether it's in line with the assumptions or not. Like for example these two figures, I mean they are clearly showing that definitely your function is not differentiable here wherever it's touching, I mean as a corner point, not a corner point but a point which is changing its nature from the point where it's touching the budget line, right? So this is about it. Now, again, so what we are concluding in this section is that the efficient way to find an optimal bundle is going to be the point where your MRS is equal to the slope of the budget line. So as we have derived this expression as well, and this is very important even for our upcoming themes which we are going to discuss, that your tangency condition must hold, and this is given as MRS equal to MUX, where X is a commodity, Y is a commodity in XY plane. Say for instance you had a commodity combination of X and Y, so your marginal utility of X to that of Y is equal to the ratio of the price of X to Y. So this is about the condition for optimal choice. And in case that if it's not going to be equal, then you can conclude that this combination is not, a particular combination is not optimal. So for instance, you are given a utility function and you are asked to check for the condition of optimality, okay, where your optimal choice lies. So you can directly calculate the MRS from a given utility function. For example, utility function u of xy is given, okay, and you have a budget line also given, price times x1, price time x2. Now it can be in any form. I'm just giving a general representation to it. It can be in any form. I mean, it can be x1 x2 square as well. This can be cube as well. I mean, it can be within the roots also, any functional form along with the budget line. So you can calculate the slope of both these curves, right, of the budget line as well as the utility function. And in case it's not going to be equal, I mean their slopes, then it's not giving you an optimal solution, that particular combination which you're just testing for. So let's take up a small example that say for example your price ratio is given as that of 1:1 for price of X and price of Y. Their ratio is given as 1:1, and consumer is presently at a bundle where his MRS is half. So obviously when if I question that whether he is maximizing his utility or not, what would be the answer? It's as simple as you have to simply check for that condition. So if 1/1, obviously it's not equal to 1/2, so it's not an optimal solution, right? You simply have to check for the condition. But it may be asked in a way that you are given a utility function, okay, you can be f of x1 x2 or any commodity, and then your budget line is also given as a function of price and commodity, right, pixi. So then they can ask whether it's utility maximizing or not in terms of its slope and this, right, or find the optimal combination. So it can be found, I mean, with this condition simply, I mean, by equating this, and its derivation has already been discussed in the previous video. Now in the final part of this chapter, we are given a small theme which is basically talking about the tax, like how your tax reflects on the budget constraints. So obviously, like we have been discussing, that we can represent our budget constraint with price times quantity, like expression, right? This form of expression, especially for two commodity case, right? If this is x1 and this is x2, so this was our budget line, say this is AB up till here, okay? And it in general we can write it as price of I times quantity of ith good for I from 1 to n. It can be anything. I mean, even a consumer is consuming 1 unit, doesn't matter. So now there are two types of taxes which we are talking about here. One is on the quantity and the other one is on the income. Now income tax is direct, I mean it's very straight in a sense that it's directly being deducted from your income M. Say for instance consumer had initially income M, so directly a fixed amount of tax is going to be there, which is T, okay, M minus T, which will reflect in your budget constraint. So it's going to be price times x1 plus price time x2. Now your new budget line, what will happen to that? So your M, obviously when you are being taxed, so it will shift, right? Where it will shift inwards, because you're losing from your pocket, right? Initially, for instance, you had $100 to spend among these two goods. Now when you are being charged with, say for example, 20, okay, this is your tea, so now you are only left with $80 to spend on the combination of x1 and x2. So in a way your budget line has shrinked back to a prime b prime, right? So this is the implication of income tax. Now what happens in case of a quantity tax? So this is the implication of income tax, and this is your budget line, right? It's shifting backwards or inwards. So now the next case is for the quantity tax. Now say for instance, on the same budget line which we were assuming, and it can hold for n number of commodities as well. Say for example, each unit of x1, okay, tax on each unit of x1 being consumed is small t, okay. So for example, whatever amount of x1 I am going to consume, for example, like if I'm consuming 1 unit of x1, if it's costing me $5, okay, and I am being charged at the rate of 5% tax, so obviously 0.25 is going to be the tax, right? And the final price for consuming 1 unit of x1 will be 5.25, right? Likewise, if I'm consuming 2 units, it's going to be $10, right? Plus 2 times the tax amount, which is equal to what? 0.50, right? So finally I have to pay 10.5, right? If I'm consuming 3 or 4, so what will be the case for 4? It will be 20 units of any currency which you can case, like for example I'm assuming dollar. So 4 times 5% of 20, right? It will be 1, okay, and how much it will be? It will be $21. So this is how it's reflecting, right? And in terms of the budget line, if I have to observe this, that how it's affecting my budget line or the consumer, you know that this is x2 and this is x1. Your commodity x1 is being taxed here, right? This was your initial budget line AB, and when you are being taxed on additional consumption of x1, what will happen? Like as you are increasing your consumption of x1, you are paying more for what? For x1, right? So it's getting more expensive. So you can think of this kind of shift, right? So this is what I beg your pardon, yeah, it will be an inward shift. It's not outward shift again, because as x1 is getting expensive, obviously consumer would be better off consuming more of x2 and less of x1, as each additional unit costs more, right? So this will be the kind of budget line which will be resulting out of it, with A remaining same, right? So this is all about the taxation as well. I request all of you to please go through the previous lectures as well, because most of the concepts which we have encountered so far, even in this chapter, they all follow a sequence of events, I mean from the previous chapters only. I hope this helps in augmenting your learning. So thank you. Now, when we encounter the question that which tax is better, like whether income tax or the quantity tax, okay, which one is better, like in terms of the outcome for the consumer? Like we know that the impact of income tax on the consumer budget is that M is going to be subtracted with T, and his preference is going to be, like for example, he's consuming 2 units of goods, I mean 2 good combination is there. And for the quantity tax, our budget line is going to be, for example, if assuming T units of tax on x1 per each unit of x1, okay. So m plus t times x1 equals price times x1 plus price times x2. We are assuming a two commodity case. Okay, so in xy plane, say for example you have these two commodities. This is your initial budget line AB, and this is your indifference curve, which was tangent at this point. That is, this is the optimal choice. Okay, this is the original choice combination of the consumer. And now what happened when the income tax was there as a consequence of this? So your budget line basically shifted back, right? Your m minus t basically. So this shifted, right? So now say for example your optimal choice came to a point on this graph, like for example this is the point of tangency, the new tangency point from IC1 to IC2, IC1 to IC2 because of income tax T. Okay, so you shifted back here, so to point, say for example P. This is your point P for tangency. Now what happened that obviously the new combination of commodity is going to be there at point P, which is say for example x1 asterisk x2 asterisk. In case of this quantity tax, how it reflects on your budget line, like we have seen that your budget line basically was rotating as x1 is getting more expensive in a way that it's having tax associated with it. So obviously the budget line rotates inwards for the commodity x1. So say for example in same xy plane, okay, if AB was the budget line, so the new budget line is rotating inwards. This is the new budget line, and this inward shift or the rotation, not the shift, the rotation is taking place because of this TX1 in commodity X1, the tax which is being imposed, right? So we what we are going to emphasize here is, like initially we assumed that on AB the optimal combination was somewhere here at point Q. Okay, but as this line has rotated, obviously the optimal combination is going to lie where the budget line is going to be tangent, and let us say it's somewhere here at this indifference curve IC4. Okay, or let's call it IC1 and 2 only. We'll be superimposing both the graphs. So obviously this again is going to be a point like R. Okay, so given this what we are going to draw as an as a key takeaway from this is that your optimal combination at R, if you observe say for example at R, what is it implying? We moved from IC1 to IC3 because 2 is already mentioned in the first figure when we were talking about the income tax. So you again, I mean, shifted to this budget line. I mean, when the indifference curve is going to be tangent on the new budget line which has rotated because of the quantity tax, there you will be having an optimum as a consumer. So this is the new optimum. Say for example this is the new x prime and x2 prime, x1 prime and x2 prime combination, right? So this is x1 prime, x2 prime. So on the same graph, if we were to observe, obviously the point P was towards the left of Q. Okay, but as the budget line has rotated, like if I try to plot it here, okay, you will observe that the new choice which is going to be there, because the budget line has rotated inwards somewhat like here to B prime, your IC has to be tangent somewhere here, right? So your indifference curve basically is tangent at a point. I'll draw it little more clearer so that it's visible. As a consequence of this was the initial setup, right? This is, for example, point Q. When your income tax was imposed, you encountered a parallel shift, as a consequence of which your budget line also shifted inwards, and you had an optimum point of tangency here at point P. And finally, when again you are being imposed in a tax in the form of quantity tax in the later case, your budget line is basically rotating inwards like to the point B prime. Okay, and finally what you are getting as an optimal combination on this line is the point where again the budget line is going to be tangent. So say for instance it's tangent somewhere here, so it will be a point somewhere here, right? Like the point R which we had discussed in this figure. So obviously now if someone questions that ideally whether the quantity tax or the income tax affects a consumer more, or in which case the consumer is going to be better off, so it's going to be under the income tax, right? He will be better off because he can choose a point on a higher indifference curve. If you can observe here, the point P, definitely it's on a higher indifference curve as compared to the point R which is on lower indifference curve, right? This is the point P which is on IC2 if I would say, and this is IC3 which is less than below the indifference curve too. In terms of utility, it's yielding him less utility. So a consumer is better off under what? Under income tax. Under income tax, consumer is better off. All right, so this is the key takeaway. In case everyone faces the same prices for the two goods, everyone will be having same marginal rate of substitution and will be willing to trade off the goods in the same way. In the next video, we'll be talking about the concept of demand, which follows from the discussions which we had so far. If you like the content of our videos, please do like and subscribe our channel.